Hi, everybody. Welcome again. We're in the home stretch. So my name is Vipul Bhushan. In my professional life, I do risk and analytics for the investments division of a top 3 Boston-based financial asset manager. As a Boston area alum, I always love coming back to MIT and helping to put these things on and bring thought leadership together. So today we have a great panel coming up. We've got a talk and demonstration about augmented reality strategies and how it can be good for a variety of companies. So I saw a sneak preview of some of this at lunchtime at the breakout session, and I was really blown away. So I hope you enjoy it. Our 2 speakers are Jim Heppelmann. He's the president and CEO of PTC, located in Boston for the past decade. And before that, for 10 years, he was the chief technology officer at PTC. And joining him is Michael Porter. For a lot of people in the room, he really needs no introduction, but he is a professor at what I'm told is the best business school in Allston, in the Allston part of Boston. So, all right. So we're going to have a full hour. The good news is that they will be around afterwards at the Innovation Showcase reception. The bad news is we probably won't have time for question and answer during the session itself. So hold your questions and you can maybe speak to them afterwards. Thanks very much again.
Well, thank you very much, and we're very happy to be here. I'm Mike Porter, and Jim is down there, and we're going to be on opposite sides for a variety of technical reasons. So thank you all for coming, and we hope this session will be provocative, but also really informative in terms of things that you have to do and choices that your company is going to have to make. Because this digital transformation is continuing. And you know, it's not anywhere near equilibrium. We're changing and we're changing, and we're going to talk about today the most important single change going on right now, and that is augmented reality is the way most of us describe it. But we see augmented reality as really something much broader. It's really the way we connect people to the digital world. And we think that that is now the constraint, but that constraint is starting to get broken by this technology. So we're going to try to talk a little bit about the digital transformation, the trajectory we've been on for quite some years now. The digital thing started about 60 years ago. And it's been crunking and cranking and cranking. We'll talk a little bit about that. But we're now entering what we would call the 4th wave of the digital transformation. So we'll fill some of the blanks in as we go forward. Now, really the starting point here is that, you know, when we think about the digital transformation, if we kind of step back, there's really 2 fundamental pieces of business or production or any activity, commercial activity. One part is machines. And machines have had a long, important role in companies and in competition. And we know that machines have certain intrinsic benefits. Always have had certain intrinsic benefits. You know, they have physical power, they're consistent, they can deal in harsh environments, they don't complain, they don't quit, you don't have to recruit them, you can just buy them. So we have machines, and machines have had a critical place in business, in commerce. And so have humans, so have we. And I think what we're starting to get more and more insight into this actually as we enter the augmented reality era. Humans have unique advantages. They can do things that are very, very unique, and you can see some of them here. They can think and create and have ideas. They have a lot of pattern recognition we have in our senses, in our sight particularly. We can communicate in very complex ways. We have very sophisticated sensomotor skills. A human can go into any machine and repair any part They don't have to be programmed. They can kind of figure it out and adapt very quickly. So we're very adaptable. And I think that if we think about the evolution of commerce and business, it's really the relationship between these machines and the humans. Those are the two components of virtually every business that does virtually everything. And what's happened, though, is that this balance and the capabilities of machines and of humans have undergone substantial, dramatic change over the last 30 or 40 years. And this has been a fascinating topic for us to think about, because what we're finding is that this affects virtually every industry. It changes the nature of competition. It changes how companies compete and position themselves in the market. There's been a lot of opportunities opened up to compete in different ways, and we're still assimilating those. And it's going to be a long time before we assimilate all of those ideas. So Jim and I got very interested in this topic a number of years ago and started a collaboration to try to look at the evolution of what digital transformation really was, what it really meant, how it had evolved, how each stage in it had changed the capabilities. And we really started with machines, because at the time, that was where the initial revolution was beginning. And we've written a number of articles. The first two articles on the left here are about machines. And the most recent article that has come out not that long ago is really about people and connecting machines to people. And there's copies of those articles outside, and I hope there's some left. And please grab them if you're interested, because we're only going to talk about the very kind of high-level ideas here in the time we have. So what has been going on here? What is the evolution process that we are now just taking a snapshot today as we look around and understand the whole digital phenomenon? Well, it all started in what we would call wave zero, going way back in history, into the 1800s. And products at that stage were mechanical and electrical. That's what they did. And the information and data and the information processing was manual and analog. We stored data on pieces of paper, we stuck it in files, we put them in filing rooms. It was analog. The analysis we did was with slide rules and other, kind of tools that were quite simple. And that was where it all started. And we got a long way in the economy with that model. A lot of phenomenal engineers created a lot of phenomenal products that were basically mechanical and electrical. But then in the 1960s, the computer came along, and the transformation started by essentially automating the processes that companies went through in the value chain. We started automating design, CAD. We started automating order processing. We started automating all the dimensions of how companies competed using the computer instead of sort of manual analog data. And we could all of a sudden, we generated a lot of data. If you did order processing on the computer, it was easy to collect the data, store the data, analyze the data, get insight into the data. And that took place all across the value chain. What happened then was we started to get productivity improvements. Order processing with a computer is a lot more productive than order processing with a pen and a pencil and putting envelopes in, putting pages in envelopes and sending them off to the customer. That took us a number of years, a number of decades. This created a big productivity enhancement in the economy, had a tremendous impact on the ability to grow wages, and companies had a really good era taking advantage of this stage. But then eventually we went through what we would call wave two, and that was the advent of the internet. And what the internet was not something totally unique. Companies had in-house systems to exchange information around, but those were really expensive and limited to what the company was willing to invest in and put their resources in. The internet gave us very low cost, ubiquitous connectivity from anything to anything. So what did that allow us to do? Well, that allowed us to start coordinating and integrating the things we did all across the value chain, even outside the value chain. We could start connecting with our dealers, with our overseas factories. We built CRM systems, we built SCM systems, we built PLM systems, which were all about connecting the various things the company was doing across the value chain and across geography. And that, again, was another burst of productivity. And was a remarkably interesting time in the economy that we all remember. But eventually that kind of played itself out, and the real game changer happened. And that was embedding information technology not in the process of how we did stuff inside the company. That was embedding information technology into the product itself. And this is still relatively early in the evolution of the diffusion of this process. We put here around the 2010s when this really took off. And what this created, and I'll talk a little bit more about it in a minute, was although the data was piling up in these earlier stages, we had all kinds of data now on our customers, all kinds of data on our supply chain, all kinds of data about our factory, all kinds of data about a lot of stuff. And it started piling up because it was stored on the computer. The step 3, the smart connected product, or the Internet of Things, as somebody like to call it, this led to an exponential increase in the amount of data we had. So let's talk about that a little bit. Once we embed the information technology into the product through software, through storage capability, through analytics capability, and also then connecting those products to the internet, what we found was that the product changed forever. What a product is, what it could do, how we compete, what kind of choices we make, changed forever. And there were 4 critical functions that all of a sudden became possible. The first was monitoring. If we had a product with all these information technology in it, and it was connected, the product became a sensor. We could track what was happening to the product 24/7. We knew where it was. We knew whether it was on or off, whether it was operating, whether it was running fast, whether it was running slow, the condition of the product, whether it was heating up, whether something was going wrong. We could also use the product as we were measuring the world of that product to understand the external environment around that product. So, a pacemaker today that's implanted in your body can be a smart connected pacemaker. And that pacemaker can not just track how it's doing in terms of firing and whether it's been used or needed for your, to keep your heart beating in a consistent way, but the pacemaker can measure your body metrics as well as keep track of its own function. So all of a sudden we have this tremendous strategic intelligence data about all kinds of stuff that we'd never known before. Typically we sold a product, we sent it to the customer, and it was gone. We didn't know what happened. We could do customer surveys, but we only had a limited understanding of what was happening to the product. Now we know everything about the product. Even the ugly truth, like this product is only on 1 hour a day.
Just,
Sorry, thank you. That'll help. That'll help. Thanks, Jim. If that was in front of me, I would have changed that slide. Anyway, so that's monitoring. Secondly, we could start controlling the product in ways that we could never control it before. We could control the product remotely because we could control it through the internet, through the cloud. We could customize the product at almost no cost because the way the product was functioning and the degree to which the parts worked together was affected by the software. We could personalize the product very easily. We had a digital user interface. Until this time, we had a manual interface in most cases. We went over we got in our car, we took the key, and we turned the key and turned the car on. That's a manual interface. And we'll come back to manual interfaces because the digital interface is, in a way, a great breakthrough. But I can tell you there's some limitations of the digital interface. When I get into my car, I would die for an on-off switch. I would die to not have to figure out what buttons to push on the screen to get my car to do what I want it to. And the digital interface has some strengths. It substantially reduces the number of parts you need to make a product for the interface part of it, but it has some limitations that we'll come back to a little bit later. With smart connected products, then, we can start to optimize their function in ways that we could never dream of before. We could optimize on a windmill, in a field of windmills, we can actually optimize the angle of attack of the blades of one machine that is based on the conditions and where the wind's blowing from. But we can also optimize the blades of every single windmill in the entire field of windmills, including the impact of this windmill on that windmill in terms of shaping and influencing the wind patterns. This kind of optimization, and the analytics that we started to build up, really had its roots in these capabilities that we had because the products became smart and connected. And then finally, and I need not talk much about this, these things build on each other. If you can monitor, and you can control, and you can optimize pretty much any of the functionality, all of a sudden you're ready for autonomy, potentially. And that's what a lot of talk is about now, is about autonomous operation, autonomous cars, autonomous adaptation. The product knows who you are. You don't have to do anything. The product just figures out it's you and then gives you whatever set of capabilities you want. So the bottom line here is a powerful, amazingly unique set of capabilities all of a sudden arose in products or in machines, if we want to use that terminology. But in a way, some of the biggest changes are still not covered, and those have to do with this notion that products are no longer isolated. This is an example from agriculture. This is a farm tractor. Way back when, there was a mechanical electrical farm tractor built by John Deere, and its job was to go around and do whatever, pull the plows or do whatever its job was, steered by a human being. And that product, built the agricultural economy of the United States, those kind of products. But what if we made that a smart product? What if we put that software in there? Then all of a sudden it could do more things. It could do them better. And so that was just a simple evolution. But what if we could make the product not only smart, but connected? And that turns out to be super important in agriculture, because if it's actually connected to the internet, and by the way, that was really hard. The internet wasn't good enough and accurate enough to actually provide the exact sense of where exactly that tractor is, which we really wanted to know. It took a while for the internet to upgrade and the capacity to do this, to actually make a smart connected tractor. And that allowed us to know exactly where the tractor was. And when we went down the field plowing and then we turned around to come the other way, we went exactly on the right line. And we didn't overlap and we didn't miss anything. That was just one simple thing we could do on farming, which really saved and improved productivity. But what's really interesting about the smart connected product era is the ability to start connecting the products together. So, there's a bunch of machines on a farm. There's the tractor, there's planters that plant the seeds, there's tillers that do tilling type operations, there are combines and harvesters. There's a whole bunch of machines. Well, what if all those machines were connected together, not just to the internet, but through the internet, connected together? And what if they could work together in sync? And that, of course, is now the reality that we see in almost any business. You no longer have a building in which you have an HVAC system and a security system and all the other systems in a building. You now have a building in which all those systems are totally connected. And they're all leveraging each other and using the information collectively to optimize various things about the building, the energy utilization, the ability to kind of monitor who was in the building and how many people and where were they and what were they doing. All that has happened, and we can even take that further, because on a farm, what you do, you've got irrigation equipment, you've got fertilizer equipment, you've got seeds, that have to be planted. And, and it's so weather sensitive that you want to know in great detail exactly what the weather is pretty much everywhere on the farm. And now with these new products, we had the capability to do that. Just for fun, let me show you an example of that. This is some smart connected precision agriculture. That's the name they use now in farming. It's not farming, it's precision agriculture. And that's because it's all done in incredible precision. So here on the left, you see harvest, combine harvesting. It's dumping the harvest that's coming out of the combine into a wagon. The wagon is being pulled by a tractor, and the combine and the tractor are absolutely synced up. They're going exact parallel. They're in the right configuration, so the seed that comes down, the harvest comes down, goes right into the right place. It doesn't go on the ground. It's not wasted. And then when the tractor gets the container for the harvest gets full, then the signal goes to the next container that kind of drives up and puts itself in that position, and then there's a disconnect, and the one that's full goes away, and the combine keeps harvesting. And not a single second is wasted, not a single seed or a single piece of the harvest is wasted. You can see on the right a planter. It's a smart planter. And all these little gadgets are planting seeds on the field. And again, it's a smart connected planter. It has all kinds of information and sensors embedded in every piece of this. And this planter can optimize the depth at which a seed is planted, every single seed, depending on the water conditions, depending on the history of the production of that square inch of land from last year, which is now able to be monitored. We can collect all this data. Which part of the field is most productive? Which part do we need to maybe put more fertilizer on? Everything now is precision. We don't just go and lay out fertilizer in a common way. We do it in an extremely disciplined, analytical way that's, again, improved productivity. And I won't go through the rest of this, but now a farmer has got a command center. The farm is running on a platform, and all the equipment and all the systems are being displayed, and the analytics is getting better and better and better to make that farm productive. So machines have come a long way. A long way. People didn't go anywhere. We're the same people. We have those unique capabilities, but those capabilities haven't been enhanced in any way through this transformation. And what we see now is that now is the key constraint. The constraint isn't the machines. The constraint isn't what to do. The constraint isn't how much data we have, even the analytics we can do. The constraint now is engaging the people that we inevitably need in almost every process in order to actually do it. And that has led to this next generation, which we call smart connected people. So the machines are smart and connected. They've got all kinds of new capabilities, but the people were kind of sitting out, we're just sitting out there wondering what's going on and trying to assimilate all this stuff. And the question is, what can we do about that? And the reason that's a problem is because we are now overwhelmed with data. We're overwhelmed with it. And this is especially true, there's this data. How do we assimilate this data? We have so many choices now. We have 25 choices on every process, or what to do next with every piece of equipment. Which choice do we pick? How do we assimilate all this knowledge that we now have? This is now the critical problem. We're doing relatively simple things now pretty efficiently, but there's a lot more opportunity to do things better and better and better, except that we can't assimilate the data and take the right action that data is telling us to take. And the critical need is with frontline workers, people on the production line. People that are sitting behind their computer, doing computer work or IT work, they're fine. They can access the data. But the people that really need the data to make choices about what to do, they're struggling. And right now, the only thing they can do is look at their laptop or look at their phone if they're out there in the front line. And those are not very powerful vehicles for actually helping the humans assimilate the data. So here's a great example of that. So this is your a GPS system. We've all lived through this. And here we have on the right, we have a screen. And the problem with digital data is it sits on 2D flat screens. Little screens, big screens, but basically it sits on screens, okay? And we have to then, this person driving this car has to look at that screen, and this screen is going to tell you what to do, where to turn, etc. And you're going to look at that screen, and there might be a lady with a British accent talking and saying, in 500 meters, turn here. And you're going to have to be listening to that lady and looking at the screen, and then looking out the window into the real world. And the profound thing happening right now has been the disconnect between the digital world, stuff sitting on screens, and the real world where you have to do things. You have to do things in the real world. You have to make choices in the real world. So how many times have I looked at my GPS screen and I look at it, I try not to run into somebody while I'm looking at it. And I try to look out and say, okay, now that it's telling me I'm going to turn right. Well, where do they mean turn right? Okay? And if you look out the window, not clear. And so you keep looking at the screen, and then you keep looking out the window, and every time you look out the window or you look at the screen, you're exposed to running into somebody or missing something, okay? So once you get that information, then you have to change the interface. Here we have a digital interface with the digital data, but in terms of what you do, then we have to shift to a physical interface to actually take action in the real world. To turn the car. And the problem is that is a huge gap. The gap between 2D, flat screen, figure out what it's trying to tell us, try to analyze that, and then turn that into what we need to do in the real world. That is the fundamental problem right now between people and digital technology. To say it another way, when you have a 2D digital interface and a 3D physical interface, there's something called cognitive distance created. You looked at the 2D, then you've got to figure out what that means for the 3D, for the real action that you're going to take, turning the wheel, putting your foot on the brake. And that cognitive distance consumes a lot of what's called cognitive load. It takes a lot of thinking and analyzing and guessing and judging, what does that mean and what do I do? And that is substantially decreasing the capability and the accuracy of the human action that results. We've got all this information. This digital technology, it knows exactly what to do. But it's got to translate that to what the people can understand they're supposed to do. That has been the huge constraint we have now. And the solution to that problem has been sort of out there in very small bits for some time. And that solution is augmented reality. That's what augmented reality is. And let's just read together. Augmented reality is a set of technologies that superimposes the relevant digital data and the relevant digital images and control options. Remember, with smart connected products, we can control them. But the question is, what control option should we use? And if we can do augmented reality, we can project all those options onto the human's view of the real world. And then it's obvious what the human should do. The human can say, okay, I get it, I do that. What we're talking about now is the digital human interface, which is what we find over and over again is the constraint. we're overwhelmed. We have too many choices. We can't figure out what we're supposed to do. And what is the right moment for things to do now? Now, this is a solution. This is an example of an augmented reality application. It's not the application of the future. It's the early applications of AR were so-called heads-up displays. And they started in fighter jets, because the last thing you wanted your fighter pilot to have to do in combat is to look down at those gauges and try to figure out whether they're supposed to turn left or right or which bogey they were looking for. But the military had no budget constraints. And so they were able to develop systems to project all the information the pilot would ever want onto the windshield. So they could look out the windshield, see the enemy, but also see the information, and put the two together in a very fast way. Early AR used the same approach. This is an automobile. Many of you may have autos now or cars now with a heads-up display. And you can see here on the right, that's projecting the information you want to know about your GPS screen, not wasting time looking at it, but just looking at what you need to know in a way that allows you to, it's obvious what you're supposed to do. So you want to know certain information. You'd like to know how fast you're going. You'd like to know exactly how far it is before your turn. But you'd like to know exactly where to turn. And you look out the window and you see these blue arrows. You know exactly what to do. That's AR. The cognitive load is gone, because the information you see is exactly the information you want to know to do exactly what you want to do. That's AR. And that was very expensive to do until quite recently. But now there's a dramatic technological revolution going on in bringing this capability to lots and lots of different applications. So I want to turn it over to Jim now, and he'll start showing you what this is and what it can do. But I will tell you, every single person in this room, no matter what you do, no matter what your industry, even if you're a librarian, or a museum worker, you're going to need to adopt this technology, because it turns out to be enormously powerful in allowing your employees and whatever value you're creating to be done better. So Jim, over to you.
Great. All right, I'd like to start with a live demonstration. You just saw a PowerPoint slide of AR, but it's kind of fun to see the real thing. So if we could switch to my phone display, I'd appreciate that. Okay, so hopefully, can you put that up on the main screen? There you go. So that's what's on my phone. And if you look at that lower right icon, you'd recognize that as Safari, a web browser. I'm going to go 2 icons to the left and launch this green one, which is also a web browser. And it's a web browser that can render information on the 2D glass, just like any web browser you've ever used, but it can also, sorry for flipping around, it can also transpose that information into the physical world. So this is, again, a 2D web page. But if I click on the bottom half, that hyperlink turns the camera on and says, let me do this, says, hey, I can put information now in the physical world. So for example, I can put a digital twin of this motorcycle. By the way, I'm using a toy motorcycle as just a prop here. It works with the real one as well, but that's a little hard to bring into the auditorium here. So for example, now I have a 3D web application that I could, whoops, sorry, I hit the back button. I did the fat finger thing. I could, for example, show you the, sorry, live demo. It's working fine, all user error. I could, for example, show you a sales and marketing perspective on it. Part of the problem is I didn't put my reading glasses on. So for example, if I wanted to show you the key features of this motorcycle, I could show you, here's what the engine is, or if I click on the front wheel, it's got these great shock absorbers. If I wanted to know, if I own that motorcycle and I wanted to know how much fuel was in it, I could say, tell me the sensors. So here I'm working again with the digital twin. What I want to do is back up intentionally this time, and I'm going to click on the top half of this icon, and I'm going to point it at the floor for a minute, because it says, hey, Jim, I'm looking for a motorcycle that's roughly shaped like this, because I have information I'd like to decorate onto that motorcycle. So please do me a favor and point the camera at it. So when I point the camera at this motorcycle, it locks on, if you will, and shows me the actual motorcycle. So now if I say, let me go into the sales and marketing mode, and for example, show you the key features. Hang on a second, I'm fighting the cord. Now you can see that I put the key features of the motorcycle on the actual motorcycle even as it drives by. And if I were to say, there's a bunch of motorcycles, tell me more about the specs of this particular one, it would tell me about the engine and the displacement and whatever key parameters there were. If I went on to purchase the motorcycle, again, I could say, okay, now I own it, tell me what the sensors say. And it says, for example, there's 2.4, 2.5 now liters of fuel in the tank, 2.4. So this would be sensor data. Sorry. Sensor data, it's got a cheap little kickstand on it here. Sensor data streaming down from the cloud and not being shown on the glass of my iPhone, but actually being transposed onto the physical motorcycle in the background. I might say, okay, tell me, is there anything I should know about how to operate this motorcycle? And now you might see on the right side a 1, 2, 3, 4. And so it says number 1, there's a clutch lever here. Number 2, there's a tool set under the seat. Number 3, there's a handbrake. Number 4, there's a steering lock. Things you ought to know about this motorcycle. I might say, are there any safety warnings or cautions? And it says, yeah, be careful because these parts get hot when you operate it, the engine and muffler and so forth. I might say, okay, I think there's a problem. Let's call the service technician. So the service technician shows up and says, assess the health of that motorcycle. And you might notice this so-called swing arm that connects to the back wheel is highlighted in yellow, meaning there's some kind of a caution being highlighted there. Now, it's not that I can see a problem. It's that I can see a motorcycle and I'm talking to the cloud about the motorcycle, and the cloud analytics, maybe predictive analytics, see a problem developing. So they're saying, hey, I want to make you aware that in this area of the motorcycle, there's a problem developing. I could even say, well, tell me about the problem. Show me the actual analytics data. So it shows me the data. And I say, okay, fine. What should I do about it as a service technician? And it says, well, there's a repair procedure. And I'll hit the play button. So step 1, remove the rear brake calipers. That's those blue parts. And the bolts come out, and then the caliper itself comes off. Step 2 is going to be remove the rear axle nut, and you see that axle nut blinks red and then screws off. Step 3 is remove the rear axle bolt, which comes out the back side, but I maybe missed that. And then step 4, remove the rear wheel assembly and take it all off. So I showed you that to make a couple of key points. We can go back to the PowerPoint here. I showed you that to make a couple of key points, which is that, first of all, AR allows me in context to visualize important information. Bits and bytes from the cloud become visible and audible to me. I see them, I hear them. The second thing is we can now provide instruction content to me. Do this, do that, walk around here, loosen this, tighten that. And I didn't show you the example here, but I'll show you some later. I could as well interact with this motorcycle. I could say start as a voice command, and the voice analog signal gets converted to a digital signal, sent up to the cloud and back down to the motorcycle, and vroom, the engine starts up. I might have buttons, dialogues, things I could push. I'll show you some more advanced examples of that in a minute. And then when you marry in some virtual reality, VR, you get an interesting concept, and that is the ability to simulate things. Now, I started with the digital motorcycle to make a point, which is that anything I could do with the physical one, for example, a repair procedure, I could do a day ahead of time with the virtual one to practice. So Michael and I have looked at this from a business standpoint, and of course, virtual reality means you replace reality. You obfuscate reality and put somebody in a virtual world. I think for the most part, it's harder to imagine how businesses would use that. But there are some important points. One is that it transcends distance. I can immerse myself in an environment that's 1,000 miles away and look around and understand what's going on, particularly if it's an accurate representation of that environment. It transcends time. I have a time machine. I can go back in time and say what was going on, how much fuel was in that motorcycle last Tuesday at noon. I can wind back the clock and immerse myself in a virtual environment and see what the data was at that point in time. It also allows me to transcend scale. You know, if I think there's a problem inside the engine, I can shrink myself down and go inside the engine and look around to see what the sensors would indicate the problem seems to be inside the engine. So these capabilities are very fundamental, and I'm going to show you some more examples and then reflect on them more. So at PTC, we have many customers using this, and I'm not really here to tell you about PTC, but of course, I do have a good source of data that I would like to tell you about. So we're talking mostly to companies that make things or operate things. So they might be manufacturers, or they might be smart cities, smart factories, smart plants. They might be doing oil and gas production using smart connected products. And so we asked our customers, and in the survey we got 134 enterprise responses. We said, what are you doing with AR? And 19% were doing training, 20% were using it for design of products and systems, 28% were using it in their manufacturing or their industrial operations, which would include supply chain and things like that. 16% were using it in marketing and sales, and 15% were using it for service and support. So the takeaway here for me is, wow, they're using it everywhere, especially everywhere there's frontline workers. And that is people that need information, but they need it in the context of the work they're doing out in the field somewhere. They're at the customer site, or in the plant, or in the factory. They're out in the real world where they just don't have a computer to bring with, and they don't frankly want a computer to bring with. Now, they could use a phone or a tablet, but you know, you're back to this cognitive distance problem Michael talked about. A lot of information coming on a very small piece of glass, and trying to figure out, when I look away from the glass, back at the job I'm supposed to do, what does it mean? Now, if you go a level deeper, you know, it's not that much more telling, other than even within these categories, there are subcategories that are broadly distributed. And there's a long tail behind this. If you added all those numbers together, you get just more than 50%. So the point really is, within each of these organizations, there are many use cases. In fact, as part of our research in industrial companies, we identified 103 use cases across the entire enterprise for the use of augmented reality as a way to deliver information to people, and especially to frontline workers out in the field. Now, I want to go through some more examples, and I'm going to start with the classic marketing and sales example that everybody knows best, and this is sort of the IKEA example. I'm in my living room, I'm thinking about buying some furniture, I want to flip through the catalog of options, I'm going to pick my favorite chair, and I'm going to drop it on the floor and position it right where I want it and see if that's what I want. So this is a way for a consumer or a customer to confirm that that's what they expected. Okay, I'll go ahead and buy it. I'll buy the chair, and I'll buy the stool that goes with it. That's the classic example people know best. But actually, we think there are much bigger opportunities. And I'd like to start with this one, which is based on a study from the National Institute of Manufacturers. This is the the Association of American Manufacturing Companies. It's the who's who of the industrial world. They do a study every year with Deloitte to project what's happening in terms of workforce needs. And what they've been seeing in recent years is a big looming skilled workforce shortage. Because what's happening in a lot of these frontline worker jobs is the experts who have been here for, 40 years are retiring. And they're taking 40 years of expertise out the door. And the first problem is we can't find a replacement, because it's just hard these days to find people who want to work in factories. They view it as low tech, low skill, I'd rather do something a little more interesting. And then the second problem is, how do you try to extract from that expert 40 years of knowledge before they go poof and disappear? And how do you pass on that 40 years of knowledge to the newbie, maybe right out of a trade school, who's going to start in their place? How do you do that? So I'm going to show you some good examples of how AR can be a very useful tool to capture and transfer expertise. So here we are in sort of a manufacturing environment. This is the gentleman who's going to retire. He doesn't look quite old enough, but nonetheless, he's going to retire. And he put on a HoloLens. So I was using a phone here, an iPhone. This guy's using the first generation HoloLens. I'll later show you some second generation HoloLens footage, which is much better. So in this case, the guy puts on the HoloLens. He fires up a piece of software that basically says, please capture what I'm going to do, because I'm going through a procedure, and I'm trying to document it for those who will follow me. So he steps through this procedure, and you're going to see here a spatial anchor. There's going to be a green anchor placed there in just 1 second. Okay, a blue anchor. That's called a spatial anchor that says, I just captured some voice, video, and photography content, which is anchored in space here. And then I came over, I did something with the robot, captured some more video content. Now I'm pointing out the players, something to do at a third waypoint. These spatial anchors are hereby called waypoints. And I'm going through my procedure. I'm doing what I do. I'm just talking it out and allowing this contraption on my head to kind of pay attention to what I'm doing and capture it all. So when he's done, he takes the device off, and we download what he did, and we might go through an editorial process. We wouldn't have to do this, but maybe it was a long process, and he stopped and had a coffee break, and we'd like to cut that out because that isn't actually part of the process. So we're going to edit it and maybe even publish a Word document, a standard operating procedure to capture that as it was done by our expert. What's more interesting, though, throw away the Word document. That's another problem with a 2D format. Let's take the edited content, put it back on the HoloLens, and put the HoloLens on the head of the newbie who's been hired to do the job. And so this particular woman, Alexa, says, I want to fire up this software, and I'm going to click this procedure called the cobot failure test. And so it says, okay, well, step 1, come over here and do what this previous guy did to reset this e-stop button at this anchor. And she says, okay, check, I did that. Step 2, come over here and put that cobot back in position, just like I showed you. And so at step 2, she does that, confirms she did that. So give her a second to confirm that. Then she's going to walk over to the pliers. It says, grab this pliers. I mean, it's a simple procedure to make this quick and fast, but pick up the pliers. And she says, okay, I got the pliers. Now come back over to location 1 and replace the tip in this cobot arm. And so she does that. And I just want to let this run for another couple seconds to finish because I want to show you something very important. And that is when she confirms I did the whole process, number 1, we know she did the whole process because we watched her. We watched her go to every location to start the process and to confirm she finished it. But we also measured how long it took. So there's an important takeaway here, which is when you're using AR, you are instrumented. You have a sensor pack, and you have edge-to-cloud connectivity capturing what you do. And we can take that to the next degree and replace the kind of classic stopwatch manufacturing or industrial engineering approach with let's just understand, for example, how that process works after person does it. And what you see here is there's an awful lot of blue lines. Like this is not an effective process because each time it's repeated, there's a lot of walking around involved. We could connect all this stuff together so you just stood there and did it and didn't waste time walking around, for example. So an important point here is when you put on a HoloLens, or frankly, if you hold a phone in your hand or anything in between, you are connected to the internet. Think of that HoloLens as a modem. And if you're old enough, you know what a modem is. If you're too young, you missed that whole wave. But if you know what a modem is, you know, modem stands for modulate, demodulate. It means convert analog signals to digital signals and convert digital signals back to analog signals. And that used to allow you, for example, from your home to use a terminal across an analog phone line, you know, a digital terminal across an analog phone line using a modem to a digital computer and back again. And I'm going to argue that's kind of what we're doing here because a HoloLens converts bits and bytes to sounds and sights. Things that I, as a human and analog being, I can process using my 5 senses. I mean, I only have 5 ports: taste, touch, smell, hearing, what am I forgetting there?
Sight.
Sight, yeah, the most important of all. Thank you. I don't have an Ethernet port. So if you have bits and bytes in the cloud and you want to pass them on to me, you have to turn it into something I can see or hear or smell or taste or what have you. And that's really what a HoloLens is doing. So it's kind of like an edge agent modem that's doing protocol translation for this biological thing out there so that now we're connected. Let me go on with more examples. Here's an example of precision work being done in a factory. This happens to be at BAE Systems up in New Hampshire. They're building hybrid bus batteries, and we have published instructions. But rather than publishing those instructions to a PDF format, again, we're publishing them to a HoloLens, And that's the instructional content floating in space in front of the worker here. So what she's doing is, again, stepping through pre-published instructional content. So the first one was kind of capturing from an expert. This is publishing from the technical publishing or the manufacturing engineering department, the specific instructions that you have to go through to complete that battery assembly accurately and so forth. Let's take a look at another fun example, which is maybe something happening in your warehouse. So here's the guy putting on his gloves. He's jumping on his forklift. It says, welcome. You'll see in the upper right, do you want to begin a pick request? And he's driving over here to get his pallet. And he says, yes. It says, OK, pick request 351. Please confirm that. He confirms it. I had the volume turned off. And then it says, OK, you're going to need to go to aisle 17, shelf 3, and get these 22 items, starting with 2 headphones. And so now look at the floor in front of the forklift. It says, keep going here. Now hang a left right down here. When you get here, you should see right in this column what you need to know. So again, this is kind of like modern navigation in the context of an industrial warehouse, helping you find exactly the information that you need very, very effectively. So that would be like dynamic navigation, a different use case yet. How about service instructions? This comes from one of our customers, Sysmex, who makes blood and urine analysis equipment that you'd find in a lab at a clinic or a hospital. And this particular machine takes blood samples and then puts some reagents in them and does its process, but occasionally it gums up. So here we're going through a process on an iPad, and it's the blood technician doing the process. So we're saying loosen that thumb screw, remove this sheet metal housing, turn this aperture cover off, grab the little swab brush, wiggle it around inside that aperture, and then put it back together. So now put the aperture cover back in place, put the sheet metal cover, turn the thumb screw, and you should be back in business. And the whole goal here was to avoid dispatching a truck. Because if we could, with IoT, know what's wrong, and with AR, explain it in a simple enough way that the blood technician could try to solve it, then that machine would be back operational in 15 minutes instead of a day later, possibly an airplane ride and a rental car later. So it's a very effective, efficient way to service products out in the field. Now, one more example I want to show you. A different example is remote support. So here we have a young worker, been hired into a very complicated-looking control room, and we're going to use a video call with AR to explain to her what to do. So she's pointing her phone, and you see somebody remotely is circling actually on the work environment in front of her. Not on the screen, because he's circling specific buttons on the screen and talking to her at the same time about what to do. And as she pans around, you'll notice that the marks actually stay on the buttons because they're not on the screen. They marked through the screen onto the environment in the background. So this is a very effective way to bring the expertise from a central location out in the field to the customer, to the technician. The expertise needed when something unexpected happens can be very directly and appropriately applied using AR. So hopefully what you saw across these examples is that we can do most of the same stuff for people that we could do for machines. We can monitor people. We know where they are. We know what they're doing. We know how long it takes. We know whether they did it, whether they did all of it. We can control to a very good degree. Perhaps guide would be a better word. We can say, go here, do this. Now go here, do that. Just follow the instructions I'm giving you mapped onto the world in front of you. And then the third thing is, just like we can optimize the application of fertilizer or whatnot in a machine, we can actually optimize the work of people as well. When we complete step 3, based on the response of the machine, I might say I changed my mind, I, the cloud, changed my mind around what should be step 4. I need you to do something different because the machine isn't responding as expected. So rather than going through rote instructions, I'm going to be giving you dynamic instructions to guide you. Much like a machine in a factory would be guided based on what it's sensing as it goes through its process. So basically the bottom line is we can connect people to the internet just like machines. And it's a powerful idea because we're sort of bringing the power of digital to people. And I would argue we haven't done that, and here's my argument. 30 years ago, when I graduated from the university as an engineer, the way we programmed machines was on inch-wide paper tape with holes punched in it. I mean, literally, a byte at a time, punched on a piece of paper tape. And we took that paper tape and we brought it to the machine and fed it into the tape reader, and it read that program, and that's what it did. 30 years later, those machines are connected with real-time 5G. They've got analytics running. It's amazing what's happened in terms of our ability to talk to machines. It's because they have an Ethernet port. Now, 30 years ago, when I got my first job, I had one of those Integral Macintoshes, if you remember, the one single unit with a keyboard in front of it. That machine had a screen about that big that had text and icons on it. And now I'd say my latest product from Apple is a smaller screen with text and icons on it. I mean, the way the cloud talks to me is almost unchanged in 30 years, at least from a fundamental basis. Yeah, it's faster, it's more colorful, it's mobile, it's connected, all that stuff. But still, I'm taking all these bits and bytes and reducing them to text and graphics and maybe sounds, you know, Alexa type stuff, when what I could be doing is instead decorating the world with them and allowing me to process that information just like I process the fact that I'm in a room full of people here at MIT right now without really thinking about it that much. So it's a very powerful concept. Now, what's sort of interesting is we can actually connect both at the same time. I've given you a couple examples, but I want to show you one more also to show the new HoloLens. So let's say there's a robot. It's connected. It's sending sensor data up, and we're sending control and optimization commands back down. Meanwhile, a person shows up with a HoloLens or a tablet. And let me back up a second here, if I can. OK, that might not work. That's fine. Yeah, here we go. So rather than showing you information about the machine, I can look through that device at the machine. And when I recognize the machine, as I did the motorcycle, then I go up to the cloud and say, tell me about that machine. And it starts mapping onto the machine the information I wanted to know, and as well gives me the ability to send commands back up through the cloud and back down to the robot while interacting with it visually and with sound. So this is a powerful concept. I want to show you a video of a customer of ours, Howden. Howden makes big industrial blowers that you'd find in a sewage treatment plant. You know, you need to put air into the water so the microbes can eat the bad stuff out and produce clean water. And so they make the kind of blowers that do that. So here is Howden. Here's a gentleman from Howden wearing one of the new HoloLenses, which flips up, flips down. These are smart glasses. Here is a gentleman in technical publishing authoring a human-machine interface against the shape of the machine. We recognize the shape of that whole system and then light it up with all the control data. And it's interactive, so if this guy walks up and the machine, for example, throws an alert like it did in the upper right, he can say, bingo, tell me about that alert. So we've simulated haptic control, touch control. It turns out you didn't actually touch anything, but it feels like you did because the button went in and you heard it go click when you did that. And so what we did here is actually allowed him to order a spare part and then showed him when the part shows up, the machine is going to have to be taken apart and it's going to go into the machine here. So that's totally changing the way that humans interact with things because we didn't have any computer screens, we didn't have any tablets. We're just interacting with the thing as if it were, you know, as if it just carried this digital interface around with it. Okay, so with that, I'm going to turn it back over to Michael, and he's going to share some thoughts on what that might all mean from a bigger picture.
Well, thank you, Jim. And I know we're throwing a lot of stuff at you here, but precious time with the precious group of people. So I think what Jim has talked about is how we have created this incredible opportunity for humans and their unique skills. We can be creative, we can think out of the box, we can understand that this is different than that very quickly. How do we optimize and integrate what has traditionally been, you know, standoffish, separate pieces of work? There's, you know, one thing that I think Jim didn't say was all these examples he showed you of that guy on the forklift in the warehouse, or those people fixing the machine, the blood analyzer machine. So that first one, what we're finding is workers can improve their productivity by 35, 40, 50%. The workers. And all of a sudden, the efficiency and effectiveness with which we can do work and people can do work is dramatically increasing across many, many applications. Jim talked about glasses. Traditionally, in the early days of AR, it's been tablets and iPhones. But that's not a very good interface because you got to do the flat screen to the real world transformation. Increasingly, it's going to turn only to sort of head-mounted glasses type interfaces. One, because that's much easier to see. You don't have to hold the tablet and point that at anything. You just see it. The data is right there in your line of sight. You have your hands free, so you can work as you see things. Production line workers today can get guided through whatever step in the production process they're doing. That somebody brand new can get on a production line and do a pretty darn good job. So we're seeing tremendous productivity enhancements on the people side. We saw them on the machine side. Now we're seeing them on the people side. We can actually now map and capture human activity. You saw how people doing processes or doing complicated human work, essentially that was captured, what they did. And Jim quickly talked about the idea of Frederick Taylor. We used to look at humans working with stopwatches. And we would write down what they did and we'd have stopwatches and that was the way we made processes more efficient. Well, now we got a whole new toolkit to make almost any process significantly better. So this is having a tremendous economic impact on productivity, on quality, on pretty much any metric we think. Humans can now be part of these systems of systems. It's not just the machines that are all connected, it's the humans that are in that system, and they can be players in that system in real time, informed with lots of relevant choices about what the choices and options are at a given moment in time, what might need to be done, what's going wrong, et cetera, et cetera. So this is having an enormous impact, a growing impact on work, on every process that uses human beings, and we're just beginning. So if we step back from all this detail about what it is, because we wanted you to see this, and get what it is. Everybody's heard of AR, but very few people understand the sheer scope with which it can impact almost everything people do and allow them to do it better. Because it's the way to get all this digital information and all this insight and all these instructions to humans in a way that's incredibly easy for them to assimilate and take action. We're having a revolution in training. Training is changing forever. We're not going to sit in a classroom anymore. We're not going to look at, have to read textbooks. We're not going to even have to use user manuals. User manuals are one of the most frustrating things on the face of the earth. Okay? You get in your car, you pull out the manual, you have to find the page, then you have to read what it says, then try to figure out what it's talking about, and then figure out what you're supposed to do, and it's just frustrating. But we'll have no more user manuals like that. You'll have a AR user manual. It'll show you on your dashboard what to do.
And could I add, Michael, it'll also take training from just in case, which is how it works today, to just in time. In the moment, just what you need to know, and we won't bother trying to make you memorize it all.
Right, exactly. So this is going to be the new way of training. This is how we're going to replace all the retiring workers. This is how we're going to make work in the factory cool again. Because these people that are doing this work are going to be tremendously empowered with this new technology. And it's going to be a very different feel to a production line job. It's enabling people to be much more productive, as I said earlier. And the final point I want to make here is it's changing the nature of competition. When you have smart connected products, and when you have this capability to kind of engage the humans in the process, you're changing the nature of competition. You're changing what people compete on. Smart connected products, for example, often mean, say you're a farm tractor manufacturer, but what you figure out is the real success of your farm tractor isn't just the tractor, it's how the tractor is connected to all these other farm instruments and farm systems. And this raises a profound question. Should you stay in the tractor industry? Is there a tractor industry left? Or do we have now a farm equipment industry or a farm systems industry? Industry boundaries are changing. How to think about what you're going to do, Can you just be a farm equipment tractor manufacturer and survive in this new world? And this is causing all kinds of industries to go through upheaval, all kinds of companies to really think hard about what they do and what choices they should make about where they want to compete and how they want to compete. This technology is allowing the business model to change. It allows everything to be a product as a system. Because you can know exactly what happens to that product, and you can get charged for the use of it, and et cetera, et cetera, et cetera. So this is changing almost everything that strategy has to confront. What business are we in? What product range should we be operating in? How should we handle billing, and how should we charge for our product? What's our business model? All those things are being upturned dramatically by this technology. So as a strategy professor, which is still the core of what I do, this is changing every single industry. And company after company that I work with has to kind of rethink strategy, even if they're doing well because of these new capabilities. So hopefully this gives you a flavor for what we believe is the next big phase. It's not that the internet wasn't important, it was important. It's not just the use of computers in the value chain was important, that was important. But we're now entering what we believe is the next big discontinuity, and everybody in this room is going to have to decide what to do about it. And you can't punt because it's so powerful. So thank you very much, and thank you, Jim. And
great, thank you.